In today's video, we're looking at another 5 Meshmixer tools for your 3D printing projects. Let's get started. How's it going, guys? Angus here from Makers Muse and welcome back to another tutorial series on Meshmixer. Now, I've mentioned before that Meshmixer is a must-have bit of software if you're into 3D printing. I use it all the time for manipulating meshes before I print, altering, changing, fixing. It's a huge suite of mesh editing tools, and it's worth noting that there was just a recent update here in January 2018, so head over to meshmixer.com and grab the latest version. The tools I'm showing in this video aren't really dependent on the latest version, but it's always good to stay up to date. So in our previous video, I went through my top 5 tools that I use all the time. In this video, we're going to go through another 5 that I don't use as much, but they're still very, very important. So let's get started with number 1, Hollow. So Hollow is a tool that you're going to want to know if you're into resin 3D printing. When you traditionally print with FDM, this bunny, for example, would not be printed solid like you see it here. It would be printed with what's known as an infill. But when you print with resin, it's a liquid that is polymerized with either UV light or another method. You can't print a infill with air. It will become solid, or you'd have resin trapped inside. Similarly, if you're printing with powder, like in an SLS system, the powder inside, even if it's not sintered, becomes trapped. So this is where the hollowing tool becomes extremely valuable and actually critical for these printing processes. So you go to Edit and then Hollow. So what Hollow will do is take your model and create a skin and hollow out the inside. So you have a certain predetermined thickness for the model itself, and the inside is just air, which you can then save material on because you're only going to print that skin. So the parameters you need to know about are offset distance, solid accuracy, mesh density, holes per hollow, and the radius and taper of those holes. So offset density is the most important figure. That's going to change the actual thickness of this skin or outside of your model. So for example, I can change this to 1 and then update it here. And you can see we get a bit more detail. Solid accuracy is how accurately it will follow that outside shape. And mesh density is how many triangles are in this shape. So it's the inside of the model, so you don't really have to worry about a high triangle count normally. But if you have a very curvy, detailed object, if you go too low on solid accuracy or mesh density, you might start to have clipping, where this inside hollow will start going through the outside of the shape. On default, it's normally fine, but if you do start having issues, for example, it takes too long to compute, you might want to ramp it down, or if you start having clipping issues, you might want to ramp it back up. Now, this is all well and good, but if we have a hollow object, it's not going to help us save material because there's nowhere for that material inside to go, which is why we now have, thankfully, holes. So we can generate holes. So I'm going to hit generate holes here, and 2 is probably advisable. You could get away with 1 depending on how large or small your model is, and you want to put them in an area where you're not going to see them, and this will create holes for that material inside to drain out. Something worth noting as well is you can actually kind of hack the hole radius. The maximum size it lets you do is 3, but for example, if I change this number to 10 and hit enter, you can make them massive if you need to. So if you need big holes in something, you can make them big. 6 is probably plenty though, and I probably only need 1 for this model. Let's generate a big one there. So you want to do it in an area where you're not going to see it. The bottom of this bunny is perfect. And then we're going to accept. And once we're done, you can see the bunny doesn't look any different, but the bottom, you can see clearly into the inside of it. It's completely hollow, and you'll be able to save heaps of material when you send it to your resin or powder 3D printer. The next tool we're going to talk about is supports. Now, I don't really use Meshmixer for supports very often myself because I use FDM machines mostly, and the supports in Meshmixer are known as tree-like supports. They're very elegant and they work well, but they're very fragile, and FDM printers often knock them over, and the standard line style support works better in my experience for those machines. But if you have a resin printer, then tree-like supports in Meshmixer are very, very good. So let me demonstrate how it works. You want to go to the Analysis tab and Overhangs. Now there's various presets you can choose, and you can actually tweak these completely using the drop-down menus. But I'm just going to go with a preset here. Let's go with Replicator 2mm defaults. And that's Replicator as in the MakerBot replicator. That's how old Meshmixer is. So I'm going to go to Generate Support, and I assume, looking at these overhang markers, that it's going to generate it under the ears and under the chin there. Let's go generate support. And here we go. So we've got these supports, and you can see why they're called tree-like. They come up and branch off, and they have these tiny little points that touch the model in various places, which you then break away afterwards. And all of these settings are customizable. Under support generator, we can change the density of the model, density of the supports. We can change the tip diameter. So the posts are 2 millimeters, but we can change the tip to, it's currently 0.5. We could change it to be larger or smaller. Again, remembering that it will touch the model and cause a little like dimple of an artifact. And base diameter is if they come from the base of the print surface and touch the model from there, then it will be like a big post to keep it well supported, because you don't want little tips touching the print surface. They'll just definitely fall over. Something I need to mention though is these supports are not manifold. They can introduce errors into your slicer. So for best for a best practice, you want to bake them into the model to then take into your slicer using the convert to solid. Now this will completely replace the original model, so it does give you an option to do a new object or replace the existing. I'll just do replace existing, and it will bake these supports into the model. As you can see here, they've lost a bit of quality because it's using the make solid algorithm, which I'll talk about make solid shortly as a tool in itself, but this will still work and support the model very well. So then you can now export this with the baked in supports to your slicing software. Just a quick tip as well, if you want to change what color your meshes are in Meshmixer, it's all customizable. You can go to shaders here. I like to work with the purple. I quite like the purple, it looks good. And the background color you can change as well. Just hold down spacebar and you can choose whatever color of the rainbow you like for your background. And one final thing while we're in this menu, you want to change how the actual triangles are portrayed. So the normals here, Meshmixer can actually smooth them visually. So if I hit here, it makes the bunny look really nice and smooth, but it's not going to print like this. Software for slicers don't smooth the triangles over for printing. So really you want to keep it on the triangle faceted and true representation mode, because if I hit W for wireframe, you can see these triangles. That's how it's going to print. So make sure you're not viewing the ultra smooth mode, because it's going to mislead you when it comes to printing. Anyway, let's go to the next tool, which is fitting, talking about triangles, which is reduce. So reduce will change the number of triangles you have in the model, namely these ones here, and it's reduce, it's going to reduce them. So to use it, hit select, and then you can select an area that you want to reduce, or just I'm going to do Control A, reduce the whole thing. We can grab the bunny there, and then we're going to edit and reduce right here. So reduce has a few different approaches you can use, a few different algorithms if you like. Percentage, triangle budget, and max deviation. Depending on what you want to do, you can actually just say how many triangles you want to use, but I quite like max deviation. It's actually quite a nice way to get a stylized look without really losing the form of the model. So this is just a default 50% max deviation with a shape preserving modifier, and that actually looks really good. So if you like the low poly look, you can actually use reduce. I know Tom just did a video on using Blender to do similar things. Go check out his video if you're interested in that kind of thing for doing artistic modifications or filters to your models. But I use reduce a lot as well for when I have 3D scans, and the 3D scans have like 1 million triangles, and I want to reduce it down to just a few 100,000 because the printer can't realize that many triangles anyway. I'm not going to do it here because it destroys my computer. It's very labor intensive for it, but you can use reduce for both aesthetic reasons and practical reasons if you need to cut the file size down of your mesh. And a bonus tool under the same umbrella of reduce is Remesh. It's a different approach, and it can be used to reduce the number of triangles or increase it by completely remeshing the model. So same geometry and same kind of look, but completely new triangles. So I can go to edit here and remesh. And Meshmixer now has many different options you can choose from, such as relative density, adaptive density, target edge length, and linear subdivision. Now, if you just want to add more triangles, linear subdivision is very dumb. It just basically cuts the triangles in half. So I can just linear subdivision, and then I can just increase our density here. So now you can see we have more triangles, but it hasn't really done anything to change the look of the model. It's still going to look the same. It just gives you more triangles to work with, which if you're like modifying the mesh in other software, that can be handy because it gives the software more points to go from. but it doesn't really do anything to make the model look smoother, for example. So we can actually go and choose a different option, such as adaptive density. Now this is very computationally intensive. As soon as I click this, the stream will probably lag, so let's just go. Okay, that took forever. It took like 10 minutes to do on these settings, and every time you change something, it will recalculate. It's done something nuts to my background, and if I show you what the model looks like now, it has smoothed some areas out, like the body here. But realistically, if you want to do this kind of thing, I can't really recommend Meshmixer for it unless you've got a really powerful computer. I found the algorithms available in Mesh Labs are a lot better, to be honest. And I do have a video here about how to use them. My favorite one called the, I think, Butterfly Subdivision. But you know it's here in case you need to use it. Moving on to the next tool, which is layout and packing. So let's say for a second you're printing a really, really complicated model with heaps and heaps of pieces, like the ones I have here. Well, there's a tool in Meshmixer to help you do layout and packing to make them in a dense area so you can print many at one time on your 3D printer. Yes, I know a lot of slicers do offer this kind of thing, but they're often kind of dumb, leave big gaps, and they don't work very well. And in the case of like, you know, the Prusa Slicer Edition kind of thing, it's not, you do it manually and it's not that efficient for packing. Well, Meshmixer's algorithm is actually really, really good, and I'll show you how to use it. So I have these models here. What we'll need to do is select a print volume. So I'm going to go to View, and I'm going to show Print Bed. Now this is set to the Zortrax M200, but you can change whatever printer you like from the drop-down menu here on the right-hand side, and you can even make your own and enter the bed size you like. But let's just pretend I'm printing on the M200. Let's go with that. So what we want to do is select all of them, like so, and we're going to go to Analysis and Layout and Packing. So you'll notice that it will move them to the most logical place on the print surface, but it's not going to reorient them to be lying down. You need to make sure they're in the correct printing orientation before you do anything. So let's just cancel this, and I'm going to make sure that this one is lying down. Edit, transform, rotate it around, so that's 90, that should be like that. And then this one's upside down, so it's going to transform this around. This is pretty typical of models you download from the internet. Okay, that's good. Except, now I want some duplicates as well, so I'm just going to select the one I want a duplicate of with the object browser, and then duplicate, so you can just, you know, create as many copies as you like. So now I've got all our copies and all the models we need to print. I'm going to go back to Analysis and Layout and Packing, and it's done a pretty darn good job. So it's this big one here is taking up a lot of space. I'm going to see if I can fit them in a bit more by doing a rotate, allowing rotation as well. This is only in the Z-axis, not others. So let's do an update here. Update. Take a little bit longer, obviously. It's being a bit more clever. But yeah, it's tried, but it just can't fit them all in. So I'm just going to turn it off again. And I'm going to update. And that's going to get rid of this one here. We can print that later, it's not going to worry about it. So let's try that again. Now this is leaving a 1mm gap between the file parts, and you can see it's pretty good, but it just can't quite figure out how to put these in there. We might change our packing quality to the to medium, and let's try from the center. Let's see how that goes. It's a bit better. We've got 3 left. Let's try from the corner again, and let's try max quality. Let's see if we can fit all of these parts in. Alright, so I turned like 2D move and rotate on to max quality. It took ages and it still couldn't get all of them. So the computer has to try really hard to do what we find very easy. Packing, especially like 3D packing as well, is very difficult for a computer. So this is free software and it's done a pretty darn good job. I'm just going to update that. But once you're happy with that, you can just move these in yourself using transform, or I can just get rid of them if I want here. Select everything, so top one, bottom one, holding shift, and I can combine that into one STL file, which I then bring into my slicer, or you can try using the print icon down here in the bottom, but I haven't set it up for anything yet. I will play with it more in future. But yeah, that's packing. I used to use it all the time when I actually worked in the 3D printing industry. Okay guys, the last tool we're going to talk about in this video is Make Solid. It's a tool you're either going to love and it's going to get you out of a bind, or it's just going to frustrate you and piss you off. Make Solid will take a arrangement of just crap, bad surfaces, non-uniform, non-manifold surfaces, and try to make them solid, manifold, watertight. In the industry, it's known as shrink wrapping. I would do it all the time to architectural models using a bit of software called iMaterialize Magics when I was working in industry. It's stupidly expensive, but it did a fantastic job. Meshmixer's tool, Make Solid, does work okay. It could be a lot better, unfortunately. It's just not quite there, but it can sometimes save you. So keep it in mind if you need to do something like repair, for example, this blaster that's red, because Meshmixer says this is a terrible, terrible mesh. Under analysis, if we go to our inspector, like we did before with easy to repair files, this isn't easy to repair. It's just going to basically just delete areas. If you can see here, it just trashes them completely. I mean, it's just losing faces left, right, and center. So what we're going to try to do is use Make Solid. So edit and Make Solid here, and it's going to try to stitch together. Now the default with fast is just not that great, but this computer is completely flogged and I can't record while doing more higher quality, like accurate sharp edge preserve, which is the highest computational power option. So I'm just going to choose fast for now, and I'm going to try increasing our solid accuracy and mesh density a little bit. Let's see how that goes. Definitely still not good enough. It looks like it's been underwater for 50 years. Pretty terrible. So what I will try is under accurate. Usually my secret bullet for making Make Solid work is to give the model an offset distance. So I'm going to give this model an offset distance of 1. We will make it a little bit puffier. We're going to lose detail, but if you're using this to influence something, or if it's small scale and it's for like a model, you might be able to get away with this. Again, this is really not how to do it properly. You need proper mesh repair software to repair these files, but let's see how it goes. And there we go, guys. So the offset has allowed this to stitch itself together. As you can see, it's definitely not perfect. If I hit W, there is tons of triangles, so you might even have to go back in to reduce the number of triangles in this mesh, because it's very, very high. It just looks black. But that's Make Solid, and it can get bad STL files working for you if you have a bit of patience and a powerful computer. But there is one other use of Make Solid that's actually more artistic in application, and that is the blocky solid type. So here I have a bunny, and if I go to blocky and update, instead of trying to make a nice smooth surface, it just turns it into these little 3D cubes, like sort of Minecraft. And you can change the size of these blocks as well by changing the cell size, so I can make them like 2. Update. That's not going to work. What about 1? Let's try 1. There you go. No guarantees that this is printable or not. You've got a few weird artifacts here, for example, but it can be fun. Hit W for wireframe to create like an artistic look of an organic model by creating these blocks. So that's the Make Solid tool. As I said, in a blue moon, you might need to use it, and it might save you if you're going to be sent a really crap STL file from someone, but be prepared to be frustrated and to, change things, wait for it to update, change, go back and forth, and end up with a really large STL file at the end. That's going to do it, guys, for this video on another 5 tips in Meshmixer. I hope you found it useful. I love this bit of software. Download links in the description. And if you did enjoy this video, guys, please consider subscribing to Makers Muse. I love to empower your creativity with 3D printing. This video has taken a very long time to record because this computer is completely stuffed. And if you'd like to help me upgrade my equipment to bring better quality to you, I'd love you to consider joining my Patreon, where I release files and updates earlier on Patreon than to anyone else. And we do a private stream once every 2 weeks, which is a lot of fun. Anyway, completely optional, and I look forward to seeing you again very shortly here on Makers Muse. Catch you later, guys. Bye.
Here's the latter half of the 20th century, and man has sent rockets into deep space. He has placed satellites into orbit.